A polarized molecule having partially positive and negative poles is called dipole. For example, consider a single molecule of hydrogen fluoride. We know that hydrogen atom and fluorine atom mutually share one pair of electrons and form a covalent bond. And this molecule, fluorine, is more electronegative than hydrogen. So it pulls the shared pair of electrons more towards itself than hydrogen, due to which electronic clouds tilt toward fluorine atom. As a result of this, partially negative charge appears on fluorine and partially positive charge appears on hydrogen. Now listen carefully. This is a single molecule. It has two poles, partially positive pole and partially negative pole due to electronegativity difference. Instead of these two, we write di because di also means two. So we say dipole. Therefore, this single molecule of hydrogen fluoride is dipole because it has two poles, positive pole and negative pole. Now what about a single molecule of chlorine gas? Is it a dipole? The answer is absolute no, because the chlorine atoms on either side pull the shared pair of electrons equally. Electronic cloud remains in between. As a result of this, no partial negative and positive charge appears on either side. Hence, it is not a dipole. Therefore, note it down that a polarized molecule is a dipole because of having positive pole and negative pole, like hydrogen fluoride. While a non-polarized molecule is not a dipole because of not having positive pole and negative pole. Now what is dipole-dipole force or what is dipole-dipole interaction? Well, consider a single molecule of hydrogen fluoride. We have learned in the previous slide that it is a dipole because it has positive pole and negative pole. Consider another molecule of hydrogen fluoride. It is also a dipole because it has positive pole and negative pole. Now we have two dipoles. This is one dipole and this is another dipole. Here, listen carefully. The negative pole of this molecule attracts the positive pole of this molecule. Let me repeat it. The negative pole of this molecule attracts the positive pole of this molecule. Due to this, attractive force generates between these two dipoles, which we call dipole-dipole force. It is because the negative pole of this molecule interact with the positive pole of this molecule and dipole-dipole force produces between them. Remember that we usually represent the dipole-dipole force with dotted line. Let me also give you another example. Consider a molecule of sulfur dioxide. In this molecule, oxygen is more electronegative than sulfur. So partially negative charges appear on oxygen atoms and partially positive charge appears on sulfur. The sulfur dioxide is a dipole due to having opposite poles. Now this dipole of sulfur dioxide will interact with other dipole of sulfur dioxide in such a way that the negative side of this dipole will attract positive side of this dipole. As a result, dipole-dipole force produces between them. Remember that due to dipole-dipole forces, millions molecules of sulfur dioxide are joined together. Thus, we learn that dipole-dipole force join together polar molecules. Finally, note it down these bonus steps. Dipole-dipole force is not a chemical bond. It is intermolecular force or intermolecular forces between molecules. It means dipole-dipole force doesn't exist between atoms. Secondly, dipole-dipole forces only exist in polar covalent compounds like HCl, sulfur dioxide, etc. it doesn't exist in non-polar covalent compounds like chlorine gas, oxygen gas, etc. Thirdly, dipole-dipole force is weak intermolecular force. Here, let me ask you, then what about the strongest intermolecular forces? Well, to learn about it, watch our next video. This was all about dipole-dipole forces.